Welcome student. Today our topic is stacks. So these are the contents of our today lectures: introduction to stack, operation on stacks, insertion algorithm of stacks, deletion algorithm of stacks, applications of stack, and infix to postfix conversion of expression. Now, that is the definition of the stack. What is the stack? Basically, stack is a linear data structure used to store the temporary data where data can be inserted or deleted at only one end. Now, another definition is that a stack is container of elements that are inserted and deleted from one end of, and that is known as a top of the stack. A stack is a linear data structure where insertion or deletion is performed at only single end, and that work on the principle of LIFO, last in first out principle. Now these are the example of the stack which we use in the real life. That is the pile of the books and that is the pile of trays. We observe in this pile of the books that the book's bottommost is put at the first time and book at the topmost is put last. Now, in this pile, if we want to remove the book or want to collect the book one by one, then last book will be selected first. So that is the basic principle of the stacks to inserting and removing the element. Similarly, that is the example of pile of the plates where we put plate one by one. Now first time plate put is the last is the current, and when we want to collect the book plates again, then last inserted plate is collected first. So that is the principle of the stacks, last in first out. Now this is the example of the stack using like as an array. Here we implement a stacks and there is a variable top. This top variable is basically introduce the current status of the stack. It means what is the current positions of the stack element, that is denoted by the top of the stack. In other words, top of the stack is the end of the stack from where we can insert or delete the elements in the array. Now here we insert A, B, C, D, F in the stacks. At the time, first time the top value is -1, that is denote the stack is the empty. When we insert any element in the stack, first we have to increase the value of the top by 1. When top increase by 1 at the time of the empty, then he gets 0. At this 0 positions, we insert the element A. Again, when we want to insert the element B, then first top will increase its value and he will get the index value 1, and in this index value we will insert the value B. Similarly, this process become continue. When top goes the max -1, it means full capacity of the stack, then that is known that stack is the overflow. Now when we want to remove or delete or pop out the any element from the stack, then first we select the position of the top variable, and after removing this element we always decrease the value of top by 1. So that is the process of deleting the element from the stack. Now, what is the basic difference between array and stack? Basically, stack is also considered like as an array, but there are some fundamental differences between arrays and stack. First difference is that in the array the elements belong to index, while the stacks are based on the principle of LIFO, last in first out. Insertion and deletion in array can be done at any index in the array, but in the stack insertion and deletion is performed only one end, that is called as a top. We can do linear search and binary search in the array, but in the stack we can do only linear search. So these are the basic difference between array and stack. Now there are some terminologies used in the stack. What is the push, what is the pop, what is the top, and what is the max. So first we learn terminology. What is the top? Top is a variable in the stack which is basically used to provide the current status of the stack. The end of the stack from where we insert or delete an element. The top always show the current status of stack. Next is the push terminology. Basically, push terminology is operations where we insert an element in the stack, and this operation is known as a push operation. Next is what is the pop. The pop is an operation of deleting or removing an element from stack, that is known as pop operation. And max basically used to define the capacity of stacks to store the data, is known as a max. Now there are basically two types of the operations performed on the stack. First push operation and second pop operation. So what we do in the push operations and how we can perform the push operations, so these are illustrated here with the block diagram. In the push operations we basically use to insert an element into a stack. When we create an stack, at the time of creating, stack is always empty, and to denote an empty stack, the top variable value is always denoted by -1. Here is the block diagram that denotes the top value is -1. It means our stack is now empty, and each cell of the stacks is also addressed by the index value 0, 1 and 2. When we insert any element in a stack, first we have to increase the value of top by 1. Here we observe that here top value at time of the empty stack, the top value was -1. So I will increase -1 by 1, the top will get the value 0. So this 0 index will be denoted by the top variable. Now in this position or this index I will put or insert an element or data. Again I want to insert the element B. So before the inserting element B in the stack, it is necessary to increase the top value by 1. When I will increase, the top will get index value 1, and at this index value I will insert the data B. Similarly, when I want to insert the element C, then top first will get the increment in its value, and getting the increments, the top value is 2, and at this index I will insert the element C. So that is the process of inserting the element in the stacks. When I got the max limit, here max limit of the stack is 3 elements, so top value is 2. It now at this condition it denotes our stack is overflow. So each time a new element is inserted into the stack, the value of top is incremented by 1 in each the inserting operation. Now here I observe that when top equals to 2, that is max minus 1, it shows that stack is overflow. When stack become the overflow, in such conditions we can't insert the new element in the stack. Now using the previous concept, we can implement the algorithm of inserting or pushing the elements in the stack. Now, so we create the insertion algorithm or push algorithm of a stack. In push operations, we basically contain stack, top variable, max variable and element. At the time of inserting, it is very necessary to check that our stack is overflow or not. So first condition is that check for the overflow, and the condition for the overflow is that if top max minus 1, it means top variable's value is max minus 1, then we can send a message that our stack is overflow, and when our stack is overflow, then we cannot perform the push operation or inserting a new element, and getting this information we will return from here. Else our stack is not overflow, then such condition first we need to increase the top variable value. So top will increase by 1, and after getting increment in top value, I will insert the new element at the stack top, and using these statements we can insert a new elements in the stacks, and after inserting we can end of our if statements and return from here. Now second operation of the stack is pop operation. As we know what is the pop operation, basically in the pop operations we remove or delete an element from array. So using this diagram we can understand basic concept of pop operations. Here there are mentions 3 elements, and our capacity of our stack is also 3. So here our stack is full, it means stack is overflow. In overflow condition we can pop or remove the element. So first I want to remove the element C. So when I will remove the element C, then top always get the decrement value by 1. Here top index value is 2. When I will remove the element C, top decrease value become 1. When I will remove the V element, then top decrease value will 0, and again when I will remove the element A, then top will become minus 1, and this is basically denote the conditions where our stack is empty, and in other words we can say that this is condition of denoting that our stack is underflow. So this is the basic concept of popping operation. So it is necessary when we do the pop operation, first we have to check the conditions regarding to the underflow. If our stack is underflow, it means empty, then we can't perform the pop operation. So there are some key points regarding to the pop operations. In the pop operation, the last inserted element is deleted from the stack, and that is work on leave operations. After deleting element, the top variable is decreased by 1. When all elements are deleted from the stack and there is no element in the stack, then this is the conditions of underflow and it is known as a underflow condition. And this underflow condition we can't perform the pop operation. Now, using this concept, we design the algorithm regarding to the pop operations. In the pop operation, we basically include stack, top variable, max, and element and data. First, when I have to perform the pop operation, then I will check the underflow condition. So, to check the underflow condition, I will make here condition if top equals to minus 1, it means value of top equals to minus 1, then I will send a message that our stack is underflow and then return from here, because in underflow conditions we can't perform the pop operation. If our stack is not underflow condition, then we can perform the pop operation. So, first statements regarding the pop operation is that for top stack top, it means the value denoted by the top will be removed and will put in the new variable data variable, and when this value will be removed, our top value will be decreased by 1. It means after that I have to decrease the index value of the top, so top equals to top minus 1, and performing this operation I will end of the if statement, and after that I return. Now, our next topic is application of the stacks. So, in the engineering, the stack have a number of the applications. First one is reversing a string. When we give the any input string and we want to put in reverse order of a string, then we have to use the stack. Matching parenthesis, conversion of the expression and evolution of expressions. So, these are the basic applications of the stacks. Now, we will consider here evaluating arithmetic expression. So, basically when we denote an expression, there are three ways: infix, prefix and postfix. So, what is the infix notation of an expression? The general way of writing an expression is known as an infix notation. In the infix notation, basically an operator is always put between two operators. This mechanism of writing any expressions, or this way of writing any expression, is known as a infix notation. Next is the prefix notation. In the prefix notation, basically an operator is always put before the operand. For example, here we see plus AB is put before the operand A and B. That is the example of the prefix notation. Third one is postfix notation. In the postfix notation, operator is always put after the operands. So, here we can consider this example. Our operand A and B is put before the operator. In other words, our operator is put after the operand A and B. So, when we define any expression, an expression is basically consist of the two things: first operand and second is operator. So, what is the operand and what is the operator? Operand is a data and operator is basically a symbol that is used to operate operands. Now, this is way of converting an infix notation into the postfix notation. So, first we consider an example. Our given expression is always mentioned in infix notation. So, we consider here 2 plus parenthesis 4 minus 1, then parent clause and multiply 3. So, this expression is basically denoted here in fixed notation. Our aim is to convert this infix notation into the postfix notation, and we have told you that in the postfix notation operand is put after the operator is put after the operand. Okay. So, when we solve this type of the expression, first we have to consider the precedency. So, in this expression we consider here that parentheses have the higher precedency. So, I have to solve this expression before. First, here 4 minus 1, 4 is data and 1 is data and minus is operator. So, I will put together 4 and 1, and after that I will put the operator minus. So, when we solve any expressions or sub expression, after solving an expression is also become an operand. Now, here we can consider this become the operand, and here 2 then plus operand and multiply 3. So, we again consider here that multiply have the higher precedence than the addition. So, I have to solve this subsection. So, using this method I have to collect the operand. So, our operand become 4, 1, minus and 3, and this operator will go back. Now, here this is completely an operand and 2 is operand and plus is operator. So, there become 2 operand and 1 operator. Now, again I want to convert it into the postfix notation. So, I will collect the operands. So, operands become 2, 4, 1, minus 3, multiply, and this operator will go back. So, this is a way of converting an infix notation into the postfix notation. So, we use here 4 steps for converting the given infix expression into the postfix notation. Now, how stack solve this type of the expressions we consider here? First, after converting this notation into the polished notation, from left to right we insert one by one content in the stack. So, first 2 will inserted, after 2 4 will inserted, after 4 1 will inserted, and after inserting this, when we encounter any operator, then corresponding or current 2 operands are popped out and perform operation along with encounter operator. So, inserting this I encounter minus. When I encounter minus, then I will popped out 2 element 1 and 4 sequentially, and then I will perform the operation between them. Their operation is minus 1, 4 minus 1 become 3, and this result will again inserted in the stack. So, new result become 3. So, after inserting 3, new element is again 3, that will be inserted in stack. Now again I consider new operator is multiply operator. So when this operator will encounter, I will pop out this two current operands and I perform the multiply operation between them, and result will again stored in the stack. Then I again encounter the plus operator. When I encounter plus operator, these two operands will pop out and perform along with the addition operator. So our result will become 11, and this 11 again will store in our stack. And after storing this result, the stack will return this result to the required function, and performing this, the stack basically free from here. So we also know that a stack is also used to perform the arithmetic operations or intermediate operation, and we can say that stacks are used to store the temporary data, because these results are stored for temporary time, and when they finish their works, the stack is finished. Or today lecture is finished, and thank you.